Hello everyone. In this video lecture, we are going to see about digital image fundamentals. I am Dr. Inbamalar, working as professor in the Department of Electronics and Communication Engineering, RMK College of Engineering and Technology. So now, let us see what is an image. An image is a two-dimensional function. So mathematically it can be represented as f of x comma y. Here x and y are the spatial coordinates, which means they will give you the location of the picture elements. F is the amplitude at any pair of coordinates x comma y, which is basically the intensity of the image at that location. So if we consider this image, this location, coordinates x comma y and the intensity level f are all infinite quantities, which means this image can be called as an analog image. Now we are going to process this image using a digital computer. So it is necessary to convert this analog image into a digital image. So if the spatial coordinates x, y and the amplitude values of the function f are all made finite and discrete quantities, we can call the image as a digital image. So if x, y are discrete and f is finite and discrete, then that image is called a digital image. So we can say a digital image is composed of a finite number of elements called pixels. Pixels means picture elements. So each of these pixels has a particular location and a value. Now let us go to an example. Let us consider the image shown in the figure. Let us consider the size of the image is 2724 cross 2336 pixels, which means mathematically this is having 2724 rows and 2336 columns. This is fundamentally a two-dimensional function which is represented using rows and columns, which means this is a matrix. So, an image is represented by a matrix. Now, location is in terms of rows and columns. Now, let us come to the amplitude level. We are going to process using a digital computer. So, let us go for digital representation. So, we need to fix the number of bits. Here, let us consider 8 bits. So, if we consider 8 bits, the levels that can be represented is 2 power 8 is equal to 256. So, 256 levels you can represent. If we consider the lower value to be 0, then the highest value is 255. Now, 0 we can assign as black and 255 we can assign as white. Now, I am going to show the picture location. Let me take the top corner. So, first row, first column, which means x is equal to 1, y is equal to 1, x comma y is equal to 1 comma 1. So, the pixel location is 1 comma 1. This will be having a corresponding amplitude or intensity level, and from the figure you could see the amplitude level is 103. So, at the location 1 comma 1, the intensity level is 103. Now, let us see another example. Let me come to the bottommost corner. So, this image is of size 2724 cross 2336. So, the corner will be having a location x is equal to 2724, y is equal to 2336, which means x comma y, that is the pixel location is 2724 comma 2336, and the intensity at this level is 88. Now I am going to show a small area which comprises of many pixels. So here the area considered in this picture ranges 645 to 650 rows and 1323 to 1328 columns. So here you are having 6 rows and 6 columns in this square area, and the intensity levels is also mentioned here. So like this you can locate any pixel value in this figure, which means all the pixel value will be having a particular location and the amplitude value. So now if we represent this amplitude level using 8 bits, then it will be a digital value. Remember, digitization implies that a digital image is an approximation of a real scene. You could visualize in the figure. Hope you understood the fundamentals. Thank you.